Law of sines. Sine of capital A over A equals sine of capital B over... I know the letters here don't match the format here, but we can just change the letter names and have the same result. The sine of Q over little q is equal to the sine of P over little p. Put a little tail on that thing. Now, in the triangle that we're drawn, that doesn't have ABCs, it has QR and Ps, we need to put the numbers from this triangle into the law of sines. Q doesn't have an angle measure next to it. So we're going to leave that one as a letter for now, and we'll use that method in a second to go ahead and solve for it. But the side opposite Q is 22 centimeters. So I can rewrite that right there. Replacing in the formula the side opposite Q with its value. We can do the same thing with P. Instead of angle P, we can write what it amounts to, which is 51 degrees. And across from 51 degrees is little p, which is 18 centimeters. We can replace P with 18 centimeters. That is how we use the law of sines. We write it out, write the two fractions just like we've been doing this entire 2 months, 3 months. There's been a lot of stuff in this module about writing the fractions in proportions. But now you solve. So if I'm going to solve this, I'm going to multiply both sides by 22 because this is the denominator of this fraction where the letter that we don't know is located. So multiply both sides by 22 centimeters. And that would be this side also by 22 centimeters. The reason for multiplying by 22 centimeters is this 22 and this 22 create a fraction where when you reduce that fraction, you get a 1. So these are going to cancel out. So now we have the sine of Q. And it's an angle, so it's got to be capitalized. That's important. Capital letters for angles, lowercase letters for sides, is equal to 22 centimeters. Actually, the centimeters will cancel out as well. Times sine of 51 degrees over 18. That's right. There's more to do. I don't want to go to the calculator yet with this. I guess I'll show you, but I'm not writing it down. I can do 22 times sine of 51. Make sure you keep pressing the right button to bump your way outside of the parentheses. Close parentheses. Be in degree mode. Divide by 18. Okay, so this fraction equals 0.9498. But I don't need to write that. I do have the yellow calculator. What I need to remind you of is if you don't know the angle, use arc cosine. No, stop. Use arc sine to expose the angle that's in the sine ratio. Arc sine of both sides. I got to fit it in the front. Right here, it doesn't go at the end. It's a function. It's function notation to have it this way. Arc sine and sine will reduce. And so the measure of angle Q is going to be arc sine of this fraction. In the calculator, arc sine is written with the -1 notation. And then all of this will go in the parentheses of sine inverse. It'll look something like this. Arc sine. And if you want a fraction, you can go control divide to make a fraction. 22 times sine of 51. And on the bottom, divide by 18. Boom. It's a 71.777 degree angle. Approximately 71.78 degrees. 71.78 degrees. Question 4. What did you learn about that? Why, question for you to think about. How did you label the sides and angles of the triangle? Labeling angle, opposite side, angle, opposite side. That's what goes into our law of sines ratio. Let's go to the next question. Question 5. In triangle ABC, side little c measures 35 inches, and side B measures 28 inches, and the measure of angle B is 40. So we can take this, and this, and put them into the law of sines formula. We only need two fractions, by the way. I know there's three because there's three, sides of a triangle and three angles of a triangle, but we only need two sides and angles that are like across from each other to make the law of sines work. We don't need all three fractions, just the two that work for us. So we're going to have sine 40 because that's angle B, and 28 because that's the inches. This is correct. Taggart set it up correctly. Sine of angle C, and then the side 35, all of this I agree with. So I guess the question is now, how is this person solving for the angle? It looks like they cross multiplied, so I agree with that. Then it seems that there's some sort of calculation, like 35 times sine 40. I'm just going to check this to see if I do get 22.5. So 35 times sine 40. Yeah, that's 22.4976 to be more accurate, but they're close. The rest of this is fine. So this is okay. Now it looks like they're probably dividing by 28. So in the calculator, the nice thing is if there's an answer right here and you want to then divide by 28, you don't have to retype it. You just press the divide sign and the calculator says, do you mean that answer? In fact, most calculators, Desmos, Google, even Siri, will remember the last decimal number that you wanted from them, and then they'll do something with it. So I'm going to divide right now by 28, and I get, yeah, that's right too. Okay, so this is right. How did they get 53.1 degrees? If you don't know the oh, I see what you did. They took this number and put it right there in the sine formula. That is wrong. But let's do what we should do. What you should do is use sine inverse of the answer. Well, wait, that's close to right. Maybe that's a typo. Okay, so I'm going to try exactly what they did. Sine inverse of 0.8. No, yep, okay, wait, there's a typo here. So typo, no inverse is written, right? There needs to be an inverse in that location. But then the rest of this is fine. Angle C could be, ooh. I don't agree with that. This is like the other degree. Yes, there are two angles that have a sine value of 0.8. Yo, yes, correct. There are two angles that have a sine of 0.8. One of them is 53.1 and the other is 126.9. Acute versus obtuse. This is the problem with law of sines. If the triangle is an acute triangle, law of sines is perfect. But if the triangle could possibly be obtuse, law of sines is a flawed formula. So we got to check that. We got to know that we have an acute triangle in order to then use law of sines perfectly. Or we got to be a little careful with our angle calculation. It's the angle calculation that matters. If we don't know one of the angles, there are technically two possibilities. And all of this, other than the -1 typo, all is correct. Like you should do all of those steps. Yep, yep, and yep. Just make sure you use sine inverse. Each angle is formed using the 40-degree angle and then the rest. You got to be careful. Law of sines, really easy to use. The only hiccup is if you have acute versus obtuse triangles. Thank you for watching, commenting, liking, and subscribing. We're going to learn about the law of cosines in the next section of videos. So thank you for watching. I'll see you in the next episode.